So for this section of problems, we're supposed to graph the function using the techniques, the transformation techniques that we're learning. And starting with the graph of the basic function. In this example, the basic function is y equals x squared. And we're going to transform y equals x squared by moving it down 1. So hopefully by now you're recognizing that, oh, x squared minus 1 is just down 1. But then we're going to examine the domain and range. And it says to show at least 3 key points. And so we're going to go ahead and follow that and do that. So for x squared minus 1, first of all, x squared is looking like this. So x squared goes through 0, 0, 1, 1, and 2, 4. Okay, 1, 1, 2, 4. So if we made a little xy chart for y equals x squared, 0, 0, 1, 1, 2, 4. Okay, if we subtract 1, we would drop the graph down 1 unit. So everything goes down 1 unit. And so we would draw the graph like this. And 0, 0 becomes 0, negative 1. 1, 1 becomes 1, 0. And then 2, 4 would become 2, 3. Now the domain for these functions will remain the same. Right, so from negative infinity to infinity, I'm not going to use, I don't like that pen in there. So the domain is going to be the same. But the range, on the other hand, for the y equals x squared, using interval notation, starts at 0 and goes to infinity. So all real numbers that are non-negative. And then for the range for the transformation, we would start at negative 1 and increase to infinity. So that would be how you do problem number 39. For problem number 43, same kind of, so all the problems up until 59, same problem here, same instructions. Start with the basic function, y equals radical x. Okay, 3 key points, 0, 0, 1, 1, 4, 2, right? And if we apply the transformation, first of all, let's figure out the domain. The domain would be all real numbers greater than 0. And the range would be also all real numbers, the lowest y to the highest y, greater than or equal to 0. I think I may have said greater than, but for the domain, greater than or equal to 0. If we move the graph of y equals radical x to the right 2 units, the starting point then becomes 2, 0. And this might go back to the last test we had, finding the domain of a radical function. Now the x minus 2 has to be greater than or equal to 0. In other words, x has to be greater than or equal to 2. So when we move right or left, the domain might change like it did here, but the range will always stay the same. Just moving right or left will not ever change the range. And the 3 key points, here you'd have 2, 0, 2, 0, 3, 1. So 1, 1 becomes 3, 1. And 4, 2 becomes, we moved it to the right 2, so 4, 2 becomes 6, 2. And that's it. That's it for that one. 47. So for 47, we are transforming the graph of y equals radical x. So the same graph that we just had. And what happens when we multiply that function at radical x by 4, we increase the y coordinates each by a factor of 4. So it used to be at 1, 1. We're vertically stretching it. That's when that absolute value of a is, so a is 4. When the absolute value is greater than 1, that's a vertical stretch. All right. That means we're pulling the graph up again by a factor of 4. You're just going to multiply the y coordinate here by 4. So 1, 1 becomes 1, 4. 4, 2 becomes 4, 8. So put it up there somewhere. 4, 8. And the graph gets vertically stretched. So just stretching it vertically, it'd probably be a little higher than that, but get the idea. And you could plot points. 0, 0 is still 0, 0. 1, 1 becomes 1, 4. Just multiply the y coordinates by 4. That's all you have to do. We'll multiply the y coordinates by 4. That's what that 4 on the outside of the function does. Does the domain and range change? Absolutely not. By multiplying by a factor of 4, We're not going to change the domain or the range.